Hi there. So today we're going to look at solving some problems with quadratics. Okay, so I want you to remember earlier on that I showed you a video that had a diagram that looked something like this. It was the fireball video, and it had the cannon firing off the fireball, okay, and the fireball landed, okay? So what we're going to do today is we're going to try to use our quadratics, because you can see that that's definitely a parabola. Right, so we're going to try to use our quadratics to solve some stuff with a baseball being thrown. Okay, so the baseball is going to get thrown, it lands, and there it is. Okay, now the example that you're going to see today is not horizontal distance and vertical distance. This is going to represent the height, and this is going to represent the time after the ball's thrown. So we're going to keep track of where the ball is with regards to time. Okay, so here we go. So a ball is thrown by a baseball player, and the height of the ball is given by the equation h is equal to negative 4.9 t squared plus 15t plus 2. Now you might ask yourself why I picked such a number as negative 4.9, and there's a really good answer for that, which you're going to find out if I end up teaching you calculus. Okay. So h is the height in meters, and t is the number of seconds after the ball is thrown. Okay, so let's start by, so I want to know how high is the player's arm when he throws the ball. Okay, so there's our equation. Okay, so what I'm just going to do is I'm going to keep everything organized. Okay, so the main thing is to always have the equation in mind. Okay, so keep rewriting the equation as often as you need to, because it'll help you keep track of what's going on. Now, we know that t represents the time and h represents the height. Okay, always in these problems, we're usually told either a height or a time. Okay, if we're told a height or a time, we can solve for the other one. So here, the question is, how high is the player's arm? So that's what we're being asked. And when he throws the ball, so this is the time. So right when he lets go of the ball, right, t represents the number of seconds after the ball is thrown. So right when he throws the ball, t is equal to 0, right, because no seconds have passed. Okay, so that means that t is equal to 0. So h is equal to negative 4.9 t squared plus 15t plus 2, right? So we're going to sub in t as 0. So that's going to go there, and that's going to go there. So we get negative 4.9 times 0, which is 0, plus 15 times 0, which is 0, plus 2. So the height is 2 meters. Okay? So the height of the man's arm, right, when he lets go of the ball, is 2 meters. Okay? So now let's look at the next one. When is the ball at a height of 8 meters? Okay? So when, so the question is going to be what's time? Okay? And the height of 8 meters is what we're told. Okay? So the ball is at a height of 8 meters at a certain time. Okay? So what we're going to do is we're going to rewrite our equation again. Sorry, that's B. Okay? So the height is negative 4.9 t squared minus, or sorry, plus 15t plus 2. Okay, so now we knew that the height is 8 meters, right? We're told that in the question. So 8 is equal to negative 4.9 t squared plus 15t plus 2. Now, this is standard form, so we want to use the quadratic formula, but it's not equal to 0, it's equal to 8. Okay, so what that means is that I want to bring that 8 over. So I have negative 4.9 t squared plus 15t minus 6, right? So plus 2 minus 8, because I need it to be equal to 0 for me to use the quadratic formula. And now I can use the quadratic formula with a being negative 4.9, b being 15, and c being negative 6. Okay? So here, I'm going to say that t is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? So there's what we have to figure out. Okay, so what I would like you to do now, because there's a lot of decimals and a lot of numbers going on, I would like you to pause and try to figure this out by yourself. Okay, so pause now, solve this with the calculator, and then play again when I'll give you the answer. So what we end up with is that the square root here is 107.4, or the thing under the square root. Okay. So t is equal to negative 15 plus or minus 10.36 over negative 9.8. So t is equal to negative 15 plus 10.36 over negative 9.8, 0.47, or we get another solution. T is equal to negative 15 minus 10.36 over negative 9.8, which is equal to 2.59. Okay? So we've got our two answers, right? So that means that the ball is at a height of 8 meters at 0.47 seconds, but also at 2.59 seconds. Now, why does that make sense? Well, because the ball travels like that, right? So if this is 8 meters, then of course the ball should be at a height of 8 meters twice. One time and then another time. Okay? So it's okay if we get two answers. All right? So that's that. Now, when does the ball hit the ground? Okay, so again, what we're missing is the when. And when does the ball hit the ground? So this is telling us some information. So when the ball hits the ground, we should know the height because we're looking for time. So what's the height when the ball hits the ground? Well, the height has to be 0 because it's hitting the ground, right? So now what we're going to do is we're going to do something very similar. We're going to write our equation. Okay, but this time we're going to let h be 0, right, because it's hitting the ground. So negative 4.9t squared plus 15t plus 2. Okay, so this one I'm not going to solve for you. I'd like you to solve it and bring it back to class. Okay, let's look at D. When does the ball reach a maximum height? Okay, so here's a different type of question. So it's again asking when. So we're looking for t, but it doesn't tell us what the height is. It says the maximum height. I don't know when that is. Okay, but we can tell that a maximum height really is asking for the vertex. Okay, so since it's talking about a maximum height, I want to know when the vertex is. Okay, so let's again write down the equation. Okay, and now we're looking for the vertex. Okay, so we've got options. We can factor decimals, never factor to decimals and don't want to. We can complete the square, have to factor out negative 4.9, don't want to. But remember, at the very end of the lesson last time, we talked about how we can actually spot the vertex here. Okay, so the vertex from standard form. So we talked about the fact that if this is our equation, then the x value of the vertex is at negative b over 2a. Okay, so the x value of vertex is negative b over 2a. Okay, so that means here's b, here's a. So that means that t is equal to negative b over 2a. Okay, so to actually figure that out, we can pull out our calculator and we can say negative b, so 15 negative, divided by 2a. And it says 1.53. Okay? So t is equal to 1.53. Okay? So this tells us that the ball reaches maximum height after 1.53 seconds. Okay? So the ball reaches maximum height after 1.53 seconds. Now the last question says, what's the maximum height? So now we're asked for the height, and what's the maximum height? Well, we know when the maximum height happens. So we actually know that t is equal to 1.53. Okay? We're looking for h. Okay? So all you have to do is sub that in and find out what the height is. Okay? So that's another thing that I'm going to ask you to calculate on your own and bring to class. Alright, so that's it for the video. See you guys next time.